In this video, I'm going to show you how I 3D scanned a concrete mixer truck, how I processed the data, how I modeled the parts, and how I used the model for a driver visibility scenario. Last, I'm going to prep it and then 3D print an accurate model of the vehicle. I have a lot of projects I'm working on related to 3D scanning and 3D printing, so make sure to hit the like button and subscribe. It will really help with the success of the channel. The vehicle I scanned was a late model Housby Concrete Mixer Truck on a Mack chassis. This truck is owned by Eagle Rock, who was gracious enough to allow me to come scan the vehicle on a Sunday. I have done a few mixer trucks in the past for clients, and have found that, because of all the moving parts, they are one of the most difficult projects to do. To 3D scan the vehicle, I used a Faro X130 3D scanner, which I set to 1/5 resolution and 3x quality. White vehicles generally get great data. If this was a darker color, I might set the quality to 4x. I did not scan it in color, except for a few interior scans, so the scans only took about 3.5 minutes each. Whenever I scan a vehicle, I like to start out with 6 base scans, one on each corner and one on each side, as seen here. Even on a complicated truck like this concrete mixer, these first scans produce a surprising amount of data in a small amount of time. While the scans are going, I like to take pictures at about the same position the scanner is in. These photos can be used to project color onto the finished model. These first 6 scans take 20 minutes to do. This is a bit in the future where I process the scans into a basic mesh, and you can see how much data I got from just these first 6 scans. If this was a more simple vehicle, like a box truck or a regular sedan or SUV, 6 scans would probably be adequate. Next, I do 6 more scans, this time 1 on each end and 2 more on each side. For the side scans, I lined it up with the door and then with the 5th axle. Terrestrial scanners like these only get the areas it can see, so it is important to look through the scanner position to see what the scanner can see and what is obscured. Doing these additional 6 scans brought the total scan time to about 40 minutes. Back to the mesh data, you can see how these scans filled in some missing data, like at the front of the drum, the tank behind the cab, among other areas. Next, I filled in some more gaps by doing some what I call detail scans. These scans focus on a specific area that I know the first 12 scans didn't get very well. The quality of the data not only depends on the distance, but also the angle. If the angle between the surface and the scanner is too shallow, the data will likely be less accurate on those surfaces and more coarse. Because these scans are going to be closer, I like to set the resolution down to 1/8, since the data density is proportional to the scanner distance. These lower resolution scans only take about 2 minutes each, so they go by very quickly. I do 6 of these detail scans, one behind the cab, one in front of the mixing drum, and one that points underneath the rear of the drum on each side. With the short tripod like I was using, I didn't get any data on the roof or the top of the drum. To fill this in, I take the scanner off the tripod and just place it on the roof. This scan is again 1/8 resolution. This top scan, when possible, helps a lot with filling in missing data. If I had not done this, I would have to fill in the data by interpolating the edges of the roof. Looking at the mesh data after these detail scans, you can see how much is filled in. Specifically, look at the top of the rear fenders. While the first 12 scans, there was nothing obstructing the scanner, the angle was low, so it didn't get good data. The detail scans did a good job of filling that in. To complete the exterior, I did a few scans underneath. I wasn't going for completeness here. Getting a complete model of the underside is a complicated endeavor. I just want to get enough data to reasonably model the suspension and axles. Here you can see the meshed underside data. Next, I did the interior with 3 scans at 1/8 resolution. For these, I turned on color since it can be hard to get good coverage with the pictures. I opened the door and put the scanner as close to the door as possible on each side. Then one more scan with the scanner set up in the center with the doors closed. With color, these scans take 7 minutes each. The total scan time is about an hour and a half. One more quick set of scans. I got the engine bay by scanning under the hood with 4 scans. One lined up behind the front wheel and one in front of the front wheel on each side. The meshed engine scans turned out like this. One last scan for a visibility study. I sat in the driver's seat and set the scanner up outside to get the position of my eyes. Here is the result of that one scan. While all the scans were going, I took a lot more pictures. For the wheels and tires, I like to take one orthogonal to the face of the tire, and one straight on with the tread. For documentation's sake, it is also a good idea to take pictures of the various manufacturer tags that show the vehicle identification number and other specifications. Back at my computer, I process the data by registering it in Faro Scene, which is the software that comes with the scanner. After everything was registered, I cleaned up the data, getting rid of bad data like windows and reflective surfaces. I also started categorizing the data: exterior, interior, underside, and engine. Last, I exported the data and used a series of scripts I wrote to create the process meshes. I used Rhino 3D to import the meshes. Here you can see all the meshes put together: exterior, underside, interior, and engine. The process mesh turned out great, but it's important to identify where scanners do not get good data. There's not any data on translucent surfaces, such as the windows and headlights. The scanner did get a scattering of messy data, but I removed that as it can cause headaches later. Also, scanners get confused on highly reflective surfaces, such as the front bumper. Here you can see that the front bumper did not get any data either. However, somewhat surprisingly, did get a lot of data on the chrome parts of the grille, albeit a bit messy in areas. The goal now is to use the data and pictures to make a model for an animation. This is a very time-consuming process since there are a lot of parts. Some parts, like the hood, have clean enough data that I can just use the process geometry. Other parts, like the cab, I take the time to retopologize it. Some parts are just simple geometry and are relatively easy to remodel, like the various tanks. I do some modeling in Blender and some in Rhino depending on the part. For the tires and wheels, I take the data I have and revolve a cross-section. I then use a script I created in Rhino to quickly and accurately produce the tread pattern from the pictures I took. After many hours, I came up with this. I did not project any of the photos I took onto this. I may save that process for another video. However, if you see some of my older turntable videos from 6 years ago, you can get a good idea of how that process turns out. Projecting photos can be particularly beneficial if you need to document damage. With modeling, there are always improvements that can be made, but I feel like this is more than adequate for what I want to do with it. With the model done, I then set it up to animate it, which I will do in the Canopener scene from my last video. Click the link to see how I created this scene. I used some code that I wrote to animate vehicles following a path and speeds using Rhino. I then import the keyframes into Blender. I have worked on a number of cases that involve pedestrian accidents, where it is important to demonstrate what the driver of a large vehicle like this can and can't see. These are very large vehicles, and they do have a number of blind spots. Using the animation from my last video, I added the mixer truck and a pedestrian. The pedestrian is doing what we all do too often, looking at their phone instead of paying attention. The pedestrian just misses getting hit by the box truck running the red light. The concrete mixer driver notices the pedestrian and tracks him while he crosses the street and then turns down the sidewalk. When the light turns green, the driver then turns left to avoid the risk of hitting the low bridge. Unbeknownst to the driver, the pedestrian makes a U-turn and starts crossing the street after the concrete mixer had already started making its turn, almost getting hit again. Creating 3D printed models of vehicles is something that I have been experimenting with a lot over the last year. The process can take a lot of time. Each part needs to be reprocessed, paying attention to how thick the part is and how printable it will be. The hood, for example, I just made thicker. I usually use 1 mm. The large tank behind the cab is hollowed out to reduce the amount of resin required. Interfacing parts are also given clearance. I usually use 0.5 mm. With all the parts reworked for printability, it takes at least one test print to make sure everything is going to work out. Here is my first set of prints, now resembling a decaying whale carcass at the bottom of the ocean. It looks rough, but it allowed me to identify problem areas that I overlooked. For example, the rear fenders had severe warping. The rear tower, as I called it, had insufficient supports, etc. After reworking all the problem areas from the test print, I also made windows using a sheet of acetate, cutting it out and then snapping it into some grooves I made in the cab. Using some joints I made from another project, I made it so the front wheels can steer. The tires are printed on an FDM printer with flexible material made from recycled tires. The drum was also printed on an FDM printer. Everything else was printed with standard gray resin on a Phrozen Sonic Mini 4K. The result is this accurate 1/32nd scale model of the concrete mixer truck. It measures about a foot long. Printing this model will really make you appreciate how massive these vehicles that you share the road with are. That wraps up this video. I have a lot of other unique projects I'm working on, so make sure to subscribe to this channel and hit the like button. This really helps ensure the success of a new channel. If you have any questions about this project or suggestions, make sure to leave a comment below.